Hello pupils, you are welcome to this wonderful edition of the classroom in your home. It is mathematics time, and that means it is time to have some revision this week. Hi, I'm Uncle Agbaje. Our learning objective is very simple. By the end of this lesson, you should be able to recall some important points from the lessons that you have been taught. This is our third revision class, and this will conclude it for this week. So I would like you to pay attention. Do you have your pens and pencils already? Your paper is also with you? Let's go into the work for the day. The first question says, which of these statements is true? That is, all of them are false except one. You have to identify the false one. Trapezium is a type of parallelogram. Parallelograms are a type of trapezium. All quadrilaterals are trapezoids. None of these. Which one is correct? Trapezium is a type of parallelogram. Parallelograms are a type of trapezium. All quadrilaterals are trapezoids. None of these. The correct option will be none of these is correct because trapezoids are not parallelograms. When trapezoids have one set of sides that are not parallel, parallelograms must have opposite sides parallel. Parallelograms are also not trapeziums. They are mutually exclusive. They are not the same thing. So that you're a boy or you're a girl. So that you're a parallelogram or you're a trapezium. You cannot be both. All quadrilaterals are not trapezoids. We have squares, we have rectangles. They are not trapezoids. Now, so none of these is correct. That's the correct option. Let's move on. Which of the following is not a property of a trapezoid? You've been taught about trapezoids and their properties. So which one is a property of a trapezoid? None of its angles are equal. Only one pair of opposite sides are parallel. It has no line of symmetry. It has three sides instead of four. Which one is not a property? You must have identified it by now. The correct option will be it has three sides instead of four. This is because a trapezoid is also a quadrilateral, and that means it has four sides. It cannot have three sides. So this is the wrong one. Did you get that correctly? Good job, you. Are you ready for the next one? Let's go. A trapezoid that has one line of symmetry, we have a name for it. What is it called? Remember that trapezium that you cut to the top? Is it a scalene trapezoid, a symmetrical trapezoid, an isosceles trapezoid, or an equilateral trapezoid? Answer is very simple. It is an isosceles trapezoid, which is gotten from the isosceles triangle. So you just cut off the top of an isosceles triangle and you get an isosceles trapezoid. It will still have one line of symmetry carried from the isosceles triangle. Good job, you. The next question says, how many trapezoids are there in this diagram? Now remember that game that we played? Well, this one involves trapezoids. Count the number of trapezoids you can see. Is it 2? Is it 3? Is it 6? Is it 8? Should I finish counting by now? Did I hear you say 2? No. There are 3 trapezoids in this diagram and I'll show them to you. Okay, so here we have one trapezoid here. Oh, you got that? And here we have another one. But the whole of this is also a trapezoid. So altogether there are 3 trapezoids. Now let's move on. How many squares are there in this diagram? Take your time. Is it 4 squares? Is it 6 squares? Is it 8 squares? Is it 9 squares? How many squares do you have in this diagram? Don't rush to conclusion. Count carefully. Think outside the box. Is it 4? Is it 6? Is it 8? Is it 9? Okay. So, well, let's see what the answer is. It is not 6. Neither is it 4. There are 8 squares, and I will identify them for you. So, let me just use the white ink here. So, here is 1. Here is 2. Here is 3. Here is 4. Here is 5. Here is 6. Those ones pretty easy for you to identify. But here, that's a square. And from here to That's another square, making 8 squares altogether. Did you get that correctly? Brilliant one. Let's move on. Next question says, the line that goes round a circle. The line that goes round a circle is called what? Very simple. So options are angle, 360 degrees, circle, or circumference. And I can hear some people chorusing circumference. Good job, you. That is the correct answer. Next question says, how many radii are there in a diameter? Don't forget that radii is the plural of radius. Okay, that might just feature in Auntie Fumi's lesson one of these days. So how many radii are there in a diameter? The 1 radius, 2 radii, 3 radii, or 4 radii? Well, yeah, you know the answer to that already. It is 2 radii, and these are the 2 radii. If I draw a circle like this, then the distance from the center to the point on the circumference is a radius, and then to the other end is another radius, but from here to here is a diameter. So there are 2 radii in that diameter. All right, so moving on. The distance from the center of a circle to the circumference is called, we've just talked about that. The options are diameter, radius, chord, or diagonal. Did I hear you chorus? Radius. Good job, you. That is the correct answer. The distance from the center of the circle to the circumference is the radius. Now let's move on. A straight line that touches 2 points on the circle is called, options are arc, chord, circumference, or transversal. A straight line that touches 2 points on the circle. Let me draw it for you. I don't mind. Just to joggle your memory. This is a circle. And I draw a line that touches 2 points, a straight line. What do you call that line? Well, you have the answer by now. It is a chord. Good job, you. Now let's see what this one is saying. An incomplete circumference is called what? An incomplete circumference is, we have arc, ARC, or arc, ARK, or chord, or diameter. Which one is it? An incomplete circumference. I can draw it for you. Yeah, what do we call that? Is it ARC, ARK, or CHORD, chord, or diameter? Well, you know the answer by now. Correct option is, it is the arc, ARC. I've told you that ARK is a wooden, construction like an Ark of Covenant, or the other ark that carried Moses and his people on the water. That's a boat. So okay. Now moving on. Which of these is true? Which of these is true? And remember that when you have a question of this nature, it means that all the options are false. Only one of them is true. So a chord can be curved. Is that true? An arc is a straight line. Is that true? The radius must be vertical. Is that true? Really? The radius must be straight. Is that true? Which one is true? Or are they all false? Study critically. Should have your answer by now. The correct option is, the radius must be straight. That is the only one that is true. A chord can never be curved. An arc is not a straight line. The radius doesn't have to be vertical. It can be a diagonal. It can be horizontal. But the radius must always be a straight line. That is true. Now this question says, the chord divides a circle into 2 parts. It doesn't have to be equal. The chord divides a circle into 2 parts. And each part is called what? Called A, B, what do we call them? The options are sector, segment, quadrant, semicircle. Did I hear you right? Yeah, I heard you right. You said segment. You are correct. Good job, you. Which of these is not true? And I have said that when you have questions of this nature, that means that they are all true, except one of them that is not true. So your job will be to fish out the one that is not true. So let's study this mathematical statements. When the time is 3 o'clock, a quadrant is formed. Is that true? So imagine 3 o'clock, or quickly sketch 3 o'clock. When the time is 6 o'clock, a semicircle is formed. Is that true? When the time is 12 o'clock, a segment is formed. Is that true or false? When the time is 4 o'clock, a sector is formed. Is that true or is that false? I believe you have selected your answer by now. And when the time is 3 o'clock, a quadrant is formed. That is true, because I just drew that in the previous slide. One vertical radius, one horizontal radius. You have 3 o'clock, you get a quadrant. That's 90 degrees. When the time is 6 o'clock, the long hand and the short hand will form a straight line, and you have semicircles on both sides. When the time is 12 o'clock, a segment is formed? No. No shape is formed when the time is 12 o'clock. You only have the long line and the short line on top of each other like this. Okay, so let me use this circle. When the time is 12 o'clock, this is what you have, and this is just a radius. It is not a segment, so that statement is false. False, rather, as you will see. That's the correct option. When the time is 4 o'clock, you have a sector. This is 4 o'clock. Excuse me. This is 4 o'clock, and this whole place is a sector, as we have taught in previous lessons. All right, so let's move on. Okay. The diagram is labeled in a foreign language. I don't even know the language. This diagram is labeled in a foreign language. But there is that blue purple line here. What do you think this means? What do you think it means? That word that is written above the purple, bluish purple line. Is it radius? Could that be radius written there? Or could it be a sector? Or could it be segment? Or I have no idea. Okay, I believe you all have idea. Of course you know the answer. You know what should be written there. Even if you don't know the language, you know that that partitioned blue part is a segment. So you shouldn't be saying you have no idea, because you do. You are wonderful children. Good job, you. What are nets? What are nets in the mathematics class? Is it solid shapes that can be folded into plane shapes? Is it plane shapes that can be folded into solid shapes? Is it a divider for the table tennis table? Or is it a piece of fabric that keeps out mosquito in the mathematics class? What are nets? I believe you have your answer by now. Of course you know what nets are. They are plane shapes that can be folded into solid shapes. We just did nets last week. Okay, good job you then. Which of the following must be in the nets of all prisms? All prisms must have a particular shape. Which one is it? Rectangles, triangles, quadrangles, or circles? Did I hear you right? Oh yes, I heard you right. You said rectangles, and you are correct, my friend. You are amazing. So the next question says, which of the following must be in the net of all pyramids? All pyramids must have rectangles, triangles, quadrangles, or circles. Your guess is as good as mine. All pyramids must have, in their nets, they must have triangles, because they have a flat base and the petal towards the top. Flat base, and going towards the top. That's a triangle. So they must all have triangles in the net. So let's look at some nets. Study this net. If I fold this net, what solid shape will I get? Is it a prism or a pyramid? Is it a cuboid? Is it a cylinder? Will I get a cube, or will I get a rectangle if I fold it up? You have your answer by now. Of course I'm not going to get a rectangle, because a rectangle is not a solid shape. I mean, if I fold this up, I would not get rectangle. But because it has rectangles, it has a rectangular top and a rectangular base and a rectangular top, that should tell me that I will get a rectangular prism, and that is a cuboid, my friend. I hope that's what you selected. Good job, you. The next question says, if this shape is folded up, what will be formed. Now what you need to do is just to identify the top and the bottom. So what shape will be formed? Is it a cylinder, or a cone, or a cuboid, or a pentagonal prism? Well, at least you know it's going to be some sort of prism. But what type of prism is it? Is it going to be a cylinder, a cuboid, or pentagonal prism? Well, the correct option is a pentagonal prism. And that is because the top is a pentagon, 5 sides. The bottom is a pentagon, 5 sides. And you have all the 5 rectangles attached to them. So you have a pentagonal prism. Good job, you. Next question says, this diagram is the net of what? Now observe that it has triangles. So, is it a triangle? Is it the net of a triangle? Or the net of a triangular prism? Or the net of a triangular cube? Or the net of a triangular pyramid? Have you selected your answer? Good. Now, it's not going to be the net of a triangle because a triangle is a plane shape. Plane shapes do not have nets. It's not going to be the net of a triangular prism because prisms will have rectangles. Okay? It's not going to be, oh, well, what's a triangular cube? There's nothing called a triangular cube, but it's going to be a triangular pyramid because it has triangles and the bottom is also a triangle. So it has triangles at the top. Pyramids always have triangles because they have a pointed top and a flat base. So pointed top, flat base, that's a triangle. So it is a triangular pyramid. I believe you got this right. Oh, don't mind these flaps that are beside. It's just for you to be able to hold everything together when you finally cut it out and you want to form your triangular pyramid. So that's the correct option. Now the final question for today says, the height of a room should be around what dimensions? If somebody comes to you and tells you, my room is as tall as, and gives you a dimension, which of these would be logically correct? Is it 1 meter? Is it 30 centimeters? Is it 5 meters? Is it 50 meters? Which one of them corresponds, is likely going to be the height of a room? Okay, so think about it. Have you selected your answer? You're still thinking about it? Alright, let me think about it with you as well. 1 meter, 30 centimeters, 5 meters, 50 meters. Alright, you know what? Let's eliminate some of these answers. A room can't be 1 meter tall because even a human being that's going to live in the room is more than 1 meter tall. So unless they're going to be bending down inside the room cannot be 1 meter tall. Okay, so 1 meter is out of it. It cannot be 30 centimeters in height because 30 centimeters is even smaller than, less than 1 meter. That's the length of your ruler. Nobody has a room like that, So is it going to be 5 meters or 50 meters? 5 meters, 50 meters, let's see. The last time we were talking about dimensions, we said that the length of a door is about 2 meters. So when you say 50 meters, there are 25 tools in 50. That means that you're saying that in a room you can fit 25 doors on top of each other. Now that's not possible, not unless somebody is living in a chimney. So 5 meters will be the best answer. The height of a room should be around 5 meters, as you can see. Now, is that what you selected? Good job, you. Then you have a good idea of what meters and centimeter is all about. With this, we have come to the end of this lesson. Indeed, we have come to the end of the revision classes. I will now hand you over to Uncle Popo for his own version of the revision for general science. I will come again next lesson with wonderfully packaged lessons. Till then, remain wonderful mathemagicians.